Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. I hope all of you guys are doing fine. Today we are going to discuss section number 4.2, types of programming languages, translators and integrated development environments, IDEs. Program. A program is a set of instructions that enables a computer to perform a certain task. Now, in order to write a program, you need to know or use some programming language. A programming language is basically the language in which you can write some code for the computer to act upon. Now, there are three types of programming languages: high-level languages, low-level languages, and assembly language. High-level languages are difficult for the computer to understand, but they are close to human language, hence they are easier for the programmer to learn, to code, to read, to write, and to debug. They can be used to write programs in shorter time. They are easier to debug and maintain. Maintaining a program means that if a programmer has written some program, then another programmer is able to read it and understand what that programmer has written or make modifications to it. High-level programming languages are, some of the examples are Java, C#. This is read as sharp. This hash sign is read as sharp. C#, Python, Visual Basic, etc. Low-level languages. These programming languages are difficult to understand for the humans and code in, as they are closer to the machine languages. Programs written in low-level languages take more time to develop. They are hard to debug and they are hard to maintain. An example of a low-level language is assembly language. Last but not the least, we have assembly language. It is a special type of low-level language. Programs are written in assembly language in order to control special hardware, in order to use special hardware dependent codes, in order to write codes that need less space and that perform tasks quickly. Almost all of the device driver softwares are written in assembly language, because device drivers are softwares or programs that connect a user or a system with a specific piece of hardware. If you have developed a new piece of technology, let's suppose you have developed a robotic arm and you want your to control it via your laptop, then you need to write a code for that robotic arm in assembly language. Benefits of high-level language. Programs written in high-level programming languages are easier for a programmer to read and understand. They are easier for programmer to debug. Development time is faster if it is written in a high-level language. It is easier for a programmer to maintain a program written by another programmer. Benefits of programming in low-level language. Programmer can write programs that make use of special hardware. Programmer can write programs that make use of special machine-dependent instructions in order to control a newly developed piece of hardware. It basically means you can write instructions or code in low-level languages that control specific parts of electronic components or ICs or electronic circuits. And since even the newly developed hardware or technology would be having the same type of electronic components, ICs, circuits, circuit boards, transistors, relays, resistors, capacitors, etc. So it would be possible to control it. Programs written in low-level language doesn't take up much space in memory. They perform a task very quickly. Now, the next step, we have translator softwares. We have discussed about translators in section number 4.1 as well. These are the softwares which are used to translate high-level or low-level programming language into machine code, as the computer cannot understand anything except binary 0 or 1. Hence, no matter what language you use to write your program in, for the computer to act upon it, it is always needed to be first translated into binary form or the machine code. Again, we have three types of translators: compiler, interpreter, and assembler. A compiler is a program that translates a program from high-level language into machine code. It translates the whole program in one go and produces an executable file. Executable file or exe file is a file on which you can double click and install that software. It is also known as an installer file. The translated program can be run without the use of compiler. One statement of program can be translated into several machine language instructions. A compiled program is usually distributed for general use. An interpreter. An interpreter also translates programs from high-level language into machine code. It translates programs line by line. As soon as it encounters an error, it stops then and there and does not move forward unless and until a programmer fixes that error. Whereas compiler just reads the whole program, and whenever it finds an error, it adds it to a list of errors and carry on with the translation. And at the end of the program, after reading the whole program, it displays the list of errors found to the programmer. It translates program line by line. It doesn't compiles an executable file, and the program can't run without using interpreter each time. It is often used while development of a program, whereas compiler is used in the production phase of a program when all the lines of code has been written and they have been checked and debugged. Then we run a compiler to produce an exe file and hand it over to a client for installation. Whereas during development, after writing every 50 or 20 lines of code, we run an interpreter to check whether the lines of code we have written are okay or not, or whether they contain an error or not. A single statement written in high-level language may require several machine code instructions to be executed, or you can say a single statement written in high-level language is translated into several machine code instructions. Assembler. An assembler can only translate assembly language into machine code. It also produces an executable file. One statement of assembly language is translated into one machine code instruction. Assembled programs do not need assembler to run, and they are too distributed for general use. Now we have discussed about errors in programs. So there are two types of errors when you are writing something in a programming language. One is known as a syntax error, and the other one is known as a logical error. A syntax error is an error that occurs when the written piece of code doesn't obey programming language grammar or rules. For example, the word print, this print is used in most programming languages in order to display a message on screen. So instead of print, if you write print, so the programming language code would be wrong, and this would be displayed as an error. Okay, there's some error in this line, and once you erase the extra R, then the program would run fine and show this hello world on the screen. A logical error, an error that occurs when the written piece of program doesn't do what it was meant to do. For example, you wrote a program for addition which is supposed to take two numbers input and then add them together. By mistake, when writing the program, instead of writing the formula as number 1 plus number 2, you mistakenly wrote it as number 1 minus number 2, and then when you run the program, you enter, let's suppose, 5 and 2. So you should get the answer as 8. 5 plus 3 is 8, but you get the answer 2 because your program is running perfectly, your code is correct, but it is not giving you the result you want. You want the addition of two numbers, but you're getting the subtraction of two numbers. This is an example of logical error. The program is running, the code is correct, but it is not doing what it is meant to do. Then we have IDEs, Integrated Development Environment. It is a software program that allows a programmer to write codes in high-level languages and test on them. They come equipped with interpreter and compiler, and as well as debugging tools. They also have the tendency to produce exe files. An example of it is Visual Studio. Following are the common features of IDEs. Number one, code editor. This is a part of environment called the shell and is a text editing area. Programmers can write their code in this shell. This is an example. This is the text area of Visual Studio, and over here between these two brackets you would write your code. Translator. This compiles or interprets the code when you run it. There's a button over here for it to run the code from in the file menu or on one of the ribbons, and when you click on it, either a compiler or an interpreter runs. Debugger. This is a program within the IDE that is used to detect errors. If the debugger detects error, it may suggest what the type of error is and what line it is on. Like this. Whenever the program detects an error, it highlights that line and displays a red dot over here. This is a screenshot of Visual Studio. Next we have auto completion. When a programmer types in a common function or piece of syntax, the IDE will recognize the start of the piece of code and suggests or completes it for the programmer. This saves time while programming. Like this. Editor.wrapping column is the full command. Since there are many commands and many functions in the Visual Studio which starts with the keyword editor, so as soon as the programmer has just written edit, their IDE has interpreted it as editor and it has given so many selections. You can simply click on the one you want to use and all of that line would be added over here automatically, or it would be auto completed. Next, auto corrections. Similarly to auto completion, an IDE can detect when an obvious error has been made and will suggest a correction automatically for the programmer to review. Like the keyword is supposed to be editor and there is no edit keyword, so the IDE has drawn a red wavy line over here below this word. Similarly, the example we discussed of print, if you write this in Visual Studio, there would be a red wavy line under it and the program would suggest that perhaps you are trying to write print and not PRRINT. This works just like the spell check in Microsoft Word. This also includes bracket matching, automatically closure of the bracket if you're writing a nested if loop, where the IDE will suggest or highlight closing brackets or braces that were missed out by the programmer. Auto documentation. This explains the function and purpose of the code, e.g. by noting the modules and variables used and its expected behavior, and collates this into a text file that can be used by other developers to understand how and why the code was created. This line controls if the editor should automatically format the line after typing or not, is an example of that. These type of things, as you are writing your code, these type of instructions or what you can say comments are added into a separate text file line by line, so that if another programmer is trying to take over your project, he can go through your auto documented file and know what where your program is heading, what is the scope of your program. Next we have build automation. These tools save time by automatically doing the processes that would otherwise be done by hand. They include testing or compiling, These tools are extremely useful when a program has many thousands of lines of code. They improve the quality of software, minimizing bad software builds as well as saving time and money. Then we have libraries. These provide functions that are not included in the core part of the programming language. Libraries basically include pieces of functions which have repeated use. For example, every software you make will have a close button, it will have a print button, or it will have a minimize button. So the code behind the close file button or the minimize or maximize button would already be included in the library of a program written, tested and debugged by a team of programmers, so that when you're making a software you do not need to write a code for a close button yourself. You can just use it or call it from the library as it is already placed there. These functions can be imported and used at the start of the programming code. For example, in Python, the Turtle graphics library provides access to some simple drawing and graphics tool. Last, we have pretty printing. It is the process of converting and presenting source code or other objects in a legible and attractive way. Most code editors color code the words in the program and lay out the program in a meaningful way, such as all strings shown in red, all variables names shown in green, etc. This is an example of pretty printing. Again, this is a screenshot of Visual Studio. See, written and new are the keywords of this language. This is in C#. So they are all the keywords, case, default, return, are shown in pink color. All the names of variables, drawing applet, drawing frame, drawing control, are shown in blue color. Accessible shape, these are functions. Accessible control shape, accessible graphics shape, these are functions name. They are shown in green, whereas the parameters for the functions are shown in navy blue, and so on. I hope you have understood everything. If you have any problem, feel free to ask me. Take care. Allah Hafiz.